Hello everyone. In this video we're going to be talking about derivatives, sort of the intro to calculus. This is one of my favorite topics. Alright, so a derivative is going to tell us the slope at any given point on a line or a curve. So this is going to tell us the slope at any given point, and we denote this as dy over dx. So if we're taking the derivative of a constant, okay, so our c is constant, it's just going to be 0. So if I want to take the derivative of 5, if you think about that, 5 is a straight line that goes across, so it's always going to have a slope of 0, which makes sense that the derivative is 0. If we're going to take the derivative of something to the power of n, then all we're going to do, and by the way, you can write derivative as dy over dx or f and then a little first derivative mark. If you take the derivative of something to the power of, you're just going to take that exponent, multiply it by the front, and then take 1 away from the exponent. So this was x to the third. Then it would be 3x to the power of 3 minus 1, which is x squared. So this would be 3x squared if this was x to the third. And this only works out where n is a real number. So just make sure that you're not using imaginaries and things like that. So it can be written as f tick mark x, or the first derivative of x, or dy over dx, but do not get this confused with f inverse of x. It has a little minus 1 instead of just a little tick mark there. All right, so let's start with problem number 1. We're going to find the derivative of x squared. So if we're finding the derivative of x squared, then we're going to do f and the first derivative of x squared. So that means that we're going to put the squared out in the front. So we're going to put 2, and then we're going to do 2 minus 1 up in the exponent. So this is going to be 2x to the first, but that's really just 2x. So the derivative of x squared is 2x. Okay, it's kind of funny. I was talking about the derivative of 5 because we actually are doing the derivative of 5. So let's do dy over dx of 5. If I want the slope of a constant, it's always a straight line, so it's just going to have a slope of 0. All right, now let's look at this third one, and we are going to look at the slope with this one here. So let's look at problem number 3, and we're just going to take the derivative of each individual term. So let's do dy over dx of x to the third minus 2x. So with the x to the third, we're going to put the 3 in the front. We're going to subtract 1 from the exponent. So this is going to be 3x squared. For this one, it has an exponent of 1, so I'm going to be multiplying 1 in the front. So we're going to get minus 2. And then it's going to be x to the 0 because you do 1 minus 1. So this one's going to be 3x squared and then minus 2. Okay, so you're just going down 1 on the exponent of each. Let's go see how this is the slope of x to the third minus 2x. Okay, so here's x to the third minus 2x. Let's say I wanted to find the slope at this point. And that's actually not a good point to choose because it's kind of hard to tell what that value is. So let's say we wanted to find the slope at 2. Okay, we're going to find the slope at 2. Here's our derivative, so 3x squared minus 2. And if I want to find the slope at 2, then I'm going to plug in 2 right here. Okay, so this is going to be 10. So then if I type in, or if I look at this point right here, it's going to have a slope of 10. So that means that at this particular point right here, it would be going up 10 over 1, up 10 over 1. And it'd be kind of hard to put an actual value right here. We'd actually have to create a tangent line, which is kind of funny. But anyway, just believe me that at the value of 2, it's going to have a slope of 10. So it's just going up really, really heavy right there. If we looked at the value at negative 0.816, it should be really, really close to 0. And the reason is it is having its maximum point right there. And this is actually a little bit more than negative 0.816. It has a bunch of decimals after it, which is why this isn't exactly 0. Otherwise, it would be exactly 0 because it's a maximum or minimum, which is actually a tiny little constant value that's happening right there. All right, anyway, so let's take the derivative of problem number 4. So let's just do our f inverse of 1/3 x to the 4th minus 9x squared. Okay, so we're going to move the 4 out in the front, but we're going to have to multiply. So 4 times 1/3, that's just going to be 4/3. So we're going to get 4/3, and then we're going to subtract 1, so x to the third. Then minus multiply here. So we're going to do 2 times 9, which is 18, x, and then we'd be doing 2 minus 1, which is 1. So it'd be x to the first, which is just x. Okay, let's look at problem number 5. F inverse of x equals, so we're going to put the 5, 5 times 5, that's going to be negative 25. X to the 4th, because we're subtracting 1. 4 times negative 9 is negative 36. X to the 3rd, subtracting 1. Then we're going to have 1/3 times 9, and 1/3 times 9, that is going to give us 9/3, which is just 3. And then x to the 1/3 minus 1. Okay, so let's do 1/3 minus 1. And that is going to give us negative 2/3. Okay, so negative 2/3. And then if you take the derivative of a constant on the end, that's just going to be 0. So that one actually does not work out here. But here is the derivative. All right, so let's try out number 6 now. Okay, we're going to do 4 times negative 4. So that's going to be negative 16. X to the 3rd. Okay, and then minus 2 times 2, which is 4. X to the 1st. So that's going to be just x. And then plus 0. So this is just going to be our derivative here. All right, I would love for you guys to pause this video and try the last one on your own. So please pause now and try this. Okay, so please pause this video and here we go. All right, so now we're going to take the derivative of this. Hopefully you'll be checking your answer here. So let's take the derivative of f of x. So we're going to do 7 times negative 2, that's going to be negative 14. X to the 6th plus 4 times 3, that's 12. X to the 3rd minus 3 times 1, so that's just going to be 3. X squared plus 2 times 1/3, so that's going to be 2/3 x to the 1st. Then minus 2, and then x can be x to the 0, so that's just x to the 0, which is 1. Okay, and then plus 5, and that constant is going to go away at the end. All right, hopefully you guys got this correct. If not, please let me know if you have any questions. I'd be very happy to help you out. And just by the way, with these derivatives, you're going to be multiplying the exponent by the coefficient, and then you're going to subtract 1 from the exponent. So each time, multiply, subtract, multiply, subtract, multiply, subtract. All right, hope you guys enjoyed this video. Please have a great rest of your day. Goodbye.